So what I want to do today is I want to go over the regulation of the digestive system. I want to focus more on the upper oral cavity and then the stomach and the small intestine, and just give you a snapshot of how the GI system works. So this mini lecture will go over the GI system's regulation. So there is two systems in our body that we covered in this semester that are the grand master. It's the end all be all. It's the CPU of the body, which is going to be your brain and spinal cord, right? And then within that area you have the neurons, and then you also have the endocrine system that has hormones. And there are both neuro and endocrine controls that allow our GI systems to work properly. So the first part is that how do you begin digestion, right? Number one, you probably had a day where you're maybe just waking up and then you smell some kind of food that you really like to eat. Let's say the smell of bacon, right? I think when I smell bacon, I think morning, I think breakfast, right? Breakfast food. And maybe you love the smell of coffee. Maybe you love the smell of a certain kind of berry or fruit. And that smell will oftentimes trigger the brain to begin the process of digestion. You can also trigger this by seeing food, by thinking about food, by tasting food, obviously, when you start chewing. And this is also why it's very bad practice if you ever are starving and you go shop at a grocery store, right? So that is absolutely the worst thing to do because everything looks good. So sight, smell, taste, and thought can all begin the process of digestion. And then what happens in your mouth is you have salivation. So the saliva glands, which is the parotid, the sublingual, and the submandibular glands are going to begin to juice out saliva. The saliva comes into your mouth and then begins mixing in with whatever you eat. All right, the saliva has two kinds of enzymes I'm going to talk about. One is called amylase, which breaks down large chain carbohydrates, and it also has lipase. So you begin the process of fat breakdown and carbohydrate breakdown in your mouth. And now you're getting ready to prime the body to digest, right? So the food is in your mouth, you're chewing, you're playing with it with your tongue, and eventually becomes this mash particle called the bolus. This is a term that we use to describe the food particle. It's all, and that's why they say when you swallow it, it's all the same thing, right? You could get a plate of food or you can plate something really nicely, but when you mix it and chew it and you swallow it, it's all the same stuff. And then when the swallowing occurs, your brain utilizes the cranial nerve number 10, the vagus nerve, to allow command and to condition reflexes to begin squeezing the food down. There are also smaller and shorter reflexes in your GI system that are controlled by the enteric nervous system, which do not require the brain. So just be aware that once the food gets into your GI system, the stretching and the movement can auto-rhythmically generate contraction to push the food down. And we cannot wrap up the semester without talking a little bit more about hormones, right? I hope you like hormones. I'm a big fan. It's really how the body works. The GI system also produces a set of hormones that I want to talk very briefly about. We're not going to get into the details and the weeds of this, but I want you to have heard it in this class. So this is a really cool chart that highlights some of the major GI hormones. All these hormones you see on this chart, we have not talked about any of them during chapter 11. The first hormone that I want to highlight that's made by your stomach is called gastrin. Gastrin is the hormone that stimulates your body to make acid. So it's the one that begins breakdown of protein and that makes your stomach acid. So have you ever heard of acid reflux disease? One way is to reduce the gastrin, which can help you neutralize the acid content in your stomach. The second hormone that I want to talk briefly about is called ghrelin. All right, ghrelin also starts with the letter G, also made in your stomach, but this is the one that is relatively new and novel. It's thought to have control mechanism receptors in your brain that stimulates appetite. So if you ever have a moment in your life where you're like, man, why do I have a craving? Like, what the heck is that, right? When you crave a chocolate bar, you crave Starbucks, right? Maybe it's obviously caffeine, but maybe you crave something. The craving is a weird phenomenon, and part of it is probably because of these hormones. So ghrelin plays a role. And then the third hormone on this list is we have secretin. This one is made in the small intestine, and this one does the exact opposite of ghrelin. Instead of stimulating acid, it actually is the one that neutralizes the acid. So it stimulates bicarbonate, which at this point, I hope you've seen me talk about it a couple times, HCO3 minus bicarbonate, and that's the ion that neutralizes the acid. And then the fourth one that we have on this list is called CCK, cholecystokinin. This is a very unusual one. It has about 4 to 5 functions. The main function, though, is to begin squeezing and creating the pancreatic juices to neutralize acid, but also help you maintain motility inside your gut area. So it helps you move the food along. And then the last couple of hormones that I'm just going to briefly touch upon are relevant too, because if you go into healthcare, if you go into the current stages of medicine, these are talked about hormones. One is called GIP, which stands for gastric inhibitory peptide, and its very close cousin is called GLP. So I don't want you to get confused. One is called GIP, and one is called GLP, GLP. All right, so GIP stands for gastric inhibitory peptide, and then GLP stands for glucagon-like peptide. Both of those basically inhibit gastric motion and increase insulin in the body. So those are hormones that generally will say, well, hey, I have a lot of food, and now I want to absorb those nutrients. So it makes your body want to take the sugar away. Okay, and it's interesting because that means you've ate enough food, so you're trying to lower your hunger and your food intake. So those are a quick snapshot of the hormones. You'll get a chance to read a little bit about them this week, but these are hormones that we didn't have a chance to talk about at all during the endocrine module. So let's talk a little bit about control. So the control of the gastric system and the control of the digestive system really is divided into 3 phases. We'll talk a little bit about motility. Motility is a process of moving the food down, right? You probably heard a saying where when you eat something, all you're really doing is you're pushing the food down towards the other end, right? So eventually whatever you eat is going to come out the other end of the body, which is true. That is very true. And then, of course, you have contractions of the smooth muscle that squeeze the food down, very much like when you roll a toothpaste, you're squeezing the food down, and then you're trying to get it to the other end of the tube, right? So eventually you eat a lot of food, you have this urge to go use the bathroom, and that's because you're basically really, really full, and you want to go get rid of the waste, right? So that's the opposite of the system. And of course, there are different chemicals that get secreted by the body. So one of these chemicals here that is important here is how does your body know how much acid to make? And what kind of cells do that, right? Because you think about it, acid, HCl, this is really corrosive. And when I say HCl, if you've taken chemistry before, you remember it's hydrochloric acid. It's a pH of about 2. And the pH of 2 is quite toxic, right? If you touch it on your skin, it will cause your skin to flake off a little bit. You'll have the little corrosion occurring. But in our bodies, the HCl is released by a set of cells that are controlled in a synchronized manner. The G cells that make gastrin, the D cells that make somatostatin, and the ECL cells that make histamine. So these 3 cells all play a role to tell the stomach and say, hey, there's protein, and I need to get acid in there to begin the breakdown of the food. So the 3 phases are broken down as follows. The first phase is the moment you eat something, the moment you taste something, you begin to activate what they call the cephalic phase. So this is phase number 1. This happens in your mouth and your upper neck area. The brain begins to send signals down to your stomach that says, hey, there's food coming in. And now you have to get the stomach ready to expand and begin the process of releasing acid. So the G cells do their first job of releasing gastrin. That's the gastric hormone that favors acid, right? Gas sounds like it's very toxic, and acid is toxic, so gas makes acid. And then you have the hormone made by, the chemical made by the ECL cells, which is called histamine, the same thing made by the mast cells of the body and your immune system to begin triggering this response. Okay, well, we need acid, so let's get this going. Thank goodness your stomach has a pretty thick layer of mucus. Otherwise, if your stomach didn't have that layer, then the acid might burn through, right, the lining of the submucosal layer and then lead to something called ulcers. Right? So that's why if you ever heard of peptic ulcers or small intestine ulcers, right, or even acid reflux disease, very painful. And that's when the acid is burning through the lining of the cells. And this phase lasts about, I would say, 30 minutes or so. Then once the food gets into your stomach, gets down through the esophagus, it's going to get to the phase called the gastric phase. And this is where you have the ability to trigger some other chemicals to release. And this is technically a positive feedback, right? Your body keeps on making acid until you stop eating. So this is also why if you eat at a restaurant, or if you go to eat a very, very nice meal, you might have an appetizer or something to start off, and then you eat your main course after, right? The starter really is to prime your stomach to get ready to digest. And this positive feedback basically involves that as long as you have protein, and as long as you distend or stretch your stomach, your body should keep on making acid. However, right, you don't want to be extremely acidic. That's why if you eat only a carnivore diet or only eat a lot of protein, your body becomes a little more acidic because of the stomach's ability to generate protons. Then what we have over here is that there is obviously a lot of acid, and now when it gets into your small intestine, you don't want that acid to get there, so you need to get ready to now buffer it, right? You got to try to get rid of that acidity by neutralizing some of that mixture. The mixture of food and acid in your stomach is called chyme. That's a term you'll see in this week's module. But chyme is a milky white mixture of all the food products just kind of melted together. And this is evident when you do dissections. If you look at a fetal pig or fetal cat, if the animal had food products in their stomach, you would actually be able to see it. Over here's a picture showing you what the cells look like. I know this is a cartoon, but a few things are interesting. So inside your stomach, you have these cells called the gastric pits. We're going to name them gastric. Gastric means it makes acid. And then the word pit just means it's like a little pit of cells. The first kind of cells is G cell. They make the gastrin, that's the hormone. The hormone will then get into your blood system, circulate around, reinforce the ECL cells to make histamine. So there is a positive feedback where this one leads to that one leads to that one, and then you trigger more histamine. As histamine increases, you then stimulate the parietal cells to pump out protons into your stomach. And the protons are then eventually going to join with the chloride to make HCl. So you probably even know that there's an over-the-counter medicine you could buy at the stores called Pepcid. Pepcid is a proton pump inhibitor. So if you have acid reflux, those are great over-the-counter medicine just to have. If you know you're going to eat a big meal, you're going to try to eat a lot of food in one go, you might want to have one of those to help reduce stomach acid. Otherwise, you might feel that GERD. So sometimes it also might be because of the kinds of food you eat. But it's very painful. If you know what I'm referring to, if you have like an acid reflux disease where that acid burns upwards, it is very toxic. It doesn't feel good. And sometimes that can, even over constant damage, could lead to cancers, right? That's why when the stomach acid is so corrosive, and then the cells have no match to be able to neutralize that acid. So the final phase of today's story is going to be what we call the intestinal phase. And this is going to be the end of our journey, where now the stomach has done its job to create this acidic environment, and now we want to get it into the small intestine to absorb and further break down all the nutrients. So the key words are digestion and absorption, but we can't let that acidic content burn our small intestine, right? You can't let it burn the duodenum, which is the first part of your small intestine. So you begin this gastric reflux to inhibit the gastric stimulation. You actually stop more acid from being made so that you don't have so much acidic content coming into your small intestine.